Okay, hey everybody, this is Mr. Bells again. Just wanted you to know, look at this. This is section 10-6, which is the last unit on probabilities that we're doing. And we're going to try and stay pretty basic on this one, so this might go pretty quick. We're going to look at something called a binomial distribution and a probability distribution. So in the big picture of things, we're going to look at charts like this and say that there are four events A, B, C, and D, and the probability of A happening is 0.2 and the probability of B happening is 0.3 and the probability of C happening is 0.4 and the probability of D happening is 0.1. Whenever we have a probability distribution like this, we know that if there's only four outcomes in the sample space, that the probabilities of those things have to add up to 100% or to 1 if you're adding them with the decimals. Okay, so that's what a probability distribution looks like. Now we're also going to look at something called a binomial distribution, and a binomial distribution is finding out all the probabilities when the experiment can only have two possible outcomes. Two possible outcomes. And what we like to think of that as, those two possible outcomes are success or failure. Okay? And it could be something as simple as, let's say I'm going to shoot three baskets. I'm going to shoot 3 baskets, 3 free throws. Where the only possibility is I make it, or I miss it. Right? There's no in-betweens. It either goes in or it doesn't go in. Okay? So it could be that probability is 50%. Maybe I'm just an average shooter. Sometimes I make it, sometimes I miss it. It could be that the probability is 80%. Maybe I'm a really good shooter. Maybe I am ridiculously good and the probability of making one is 95%. And you can see if this was, say, Joe, and this was Jill, and this was Susie, and I said, well, which one of them is more likely to make 2 baskets? Well, it'd be Susie. And I would say, well, what's the probability of that happening for Susie? Is to make 2 of these 3 baskets, to make 2 of the 3. Well, we know that it could be make it, miss it, make it, right? It could be make it, miss it. It could be miss it, make it, make it. And those were all possibilities of making 2 of those things. But each one of them has different probabilities. So on a binomial distribution, there's an actual formula. And it looks just like this. And again, it only works for binomials. And binomials have 2 possible outcomes, success or failure. And you have to have repeated attempts. Because if you only have 1 attempt, then it's whatever the probability is, but repeated attempts. Okay, and the formula looks like this. It's NCR. So the stuff that we did in the last section is coming back. And then it's the book will use different notation for this, but I'm going to use this. It's the probability of success. I'm going to use a little plus sign. Plus sign means success. Times the number of times that we wanted that success. Okay. In fact, we're going to use a little R here because this is how many attempts that I have. This is the number of successes. And then times the probability of failure, right? If it's a 70% chance of succeeding, then it has to be a 30% chance of failing. times how many times you would fail. So whatever number we had that wasn't successes is failures. Okay, good deal. So NCR, that's the buttons that we use on the calculator, right? Probability of success for how many successes we have times the probability of failure times how many failures we have out of the total number of attempts n. Cool. So whatever you can do with your notes that way would be awesome. So here we go. So on this first one, it says which describes a binomial experiment. Well, a binomial experiment is something that we can express with a binomial distribution. So a binomial experiment means there's only two possible outcomes. So I'm going to work my way from the bottom. It says, according to a survey, the average American spends 25 minutes commuting to work. You ask 5 randomly chosen people their commute time. Awesome. So commute time. You have to ask yourself, is there only 2 possible answers for commute time? If there's more than 2 possible answers, or less than 2 possible answers, we get rid of it. It's not a binomial experiment. This one, according to a survey, about 22% of Americans have a college degree. You ask 5 randomly chosen people where they went to college. Is where you go to college 2 possibilities? Don't think so. This one, according to a survey, the average household size is 4.31 people. You ask 5 randomly chosen people who live in separate households. How many people live in their home? Is how many people live in their home a 2 possibility outcome? The answer is, of course, no. So it better be this one. You ask 5 randomly chosen people who live in separate households whether they own a cat. Awesome. So whether you own a cat, that is definitely a yes or a no situation. And whether or not you want them to own cats or don't want them to own cats, then yes could be success or yes could be failure. It depends on your choice on which way you ask the question. But that's definitely a binomial experiment situation. Okay? So now we're going to look at some of these distribution tables first. And I'm going to go through this one kind of in a little bit of detail here. It says, let x be a random variable that represents the number of table tennis balls randomly chosen from a bag that contains 5 balls labeled 1, 3 balls labeled 2, and 2 balls labeled 3. So the values are 1, 2, or 3. Those are the 3 values on the balls. The outcomes, how many balls were labeled 1 would be 5. How many balls were labeled 2? It says there's 3 balls labeled with a 2. And how many balls are labeled 3? It says that there are 2 balls labeled 3. Good deal. So you know, again, there are, so let me draw the picture out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The 9 ping pong balls. And again, 1, 2, 3, 4, 5 of them have a 1 on them. And 3 of them, right, 1, 2, 3, 4. Well, it looks like there's 10. I miscounted on that. So 10 of them. 3 of them have a 2. So this one's a 2, and this one's a 2, and this one's a 2. And 2 of the balls have a 3 on them. And so the next thing we're going to ask is for this, looking at this chart, this probability distribution. So what's the probability of getting a 1? Well, there's 5 out of 10 balls, or a half, if I reduce. It's the probability of getting a 2. Well, there are 3 out of 10 balls, and if I reduce, it's still 3 out of 10. I can't reduce that fraction. And this one's 2 out of 10, or 1/5. So if we take a look at the decimals, you get a 0.5, you get a 0.3, and you get a 0.2, and you add all those up, and you get 1. Yes, look at that. So we said the distribution, if those are only 10 balls in this, wherever this is, it's a bag, look at that, from a bag, then our distribution should look like that. So number of balls, x, probability in terms of this. So if we're going to try and look at this, so we have, in terms of tenths, I'm just going to scratch off that tenths thing right there, and I'm going to actually write it in tenths. I think I like that better. Okay, so this one of a 1, that's the probability there. Of a 2 is the probability of 0.3, and of a 3 is probability of 0.2. So that's what that would look like, that probability distribution. Okay, so if I said, what's the probability of drawing a ball that's an odd, probability of an odd ball, then I would take a look at the odd ones, which are the 1s and the 3s, and I would say I got 0.5 here and I got 0.2 there. So 0.5 plus 0.2 equals 0.7, or 70% chance for drawing that one. Okay? So go here. So this problem deals with a spinner, and it's already showing you the probabilities up here. So you can see that this one has 1/4 or 0.25. This one has, if this is 1/4 right here, then half of 1/4 is 1/8. So this is 1/8 through 3/8, and 3/8 is 0.375. This is 1/8, so that's 0.125. And I'm not trying to be too fancy here. If you put 3/8 into your calculator, you get that as a decimal. You put 1 divided by 8 into your calculator, you get that as a decimal too. And then this one's 0.25 again. And if I add up 0.25 and 0.375 and 0.125 and 0.25, if I add those up, I'm going to get 1 or 100%. So it says, according to the probability distribution, the number that is most likely to be spun on a spinner is the number 2, 37.5% of the time that should happen. According to the probability distribution, probability of spinning an even number is, well, even number is the probabilities of the two evens up there added together. Okay, and you can do that, fill that in on your own without much trouble. Okay, now flip it. This one right here is the exact same thing. So I'm not going to do anything with this one. I believe that you are very capable based on what we just did on that last one. The one thing I will tell you is that each one of these little sections happens to be 1/12, because that's 1/6 cut in half, so that would be 1/12, half of 1/6. And that might help you as you count up your total amounts in each one of those things in terms of twelfths. Okay, so here we go. Exercise 11. Exercise 11 is where we get into those binomial distribution things. That was this stuff we talked about right down here before in the other one. So I'm going to try and do this one. It says, calculate the probability of flipping a coin 20 times and getting 18 heads. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 20. What am I doing? 20 coins and getting 18 heads. I think this is where, and I preach this all the time, and I wish I would have been able to see you guys in class more. But I try and preach something called, I call it DIMS, D-I-M-S. It's all over my room. It's on my board, on my calculator and stuff. It says, for does it make sense? Because Lord knows life people need a little bit more common sense. And sometimes really, really smart people don't have much of it at all. So we're hoping for some common sense. So the first thing I'm going to ask you is this. If I flip it 20 times, what do you guys think? Am I going to get 18 heads a lot? And hopefully your answer is going to be, no, Mr. Bowles, we are not going to get 18 heads a lot. That's so rare. We should get 10 heads, right? We should get 10 heads and 10 tables. But there's a probability that it actually could happen. It's going to be small, but there's a probability that it could happen. Okay, so how does this work out? Well, basically, before I do the actual math, let me do this. Do you agree that I could get a head on everything but these two? Yeah. Do you agree that I could get a head on everything except for these two? Yeah. Do you agree that I could get everything on a head except for these two? Well, yeah. Well, there's a lot of different possibilities of getting those 18 heads. And that's where that big funky formula comes into play is, well, how many different possibilities are there? Well, we know the formula was NCR, right? Times probability of success times the probability of failure for how many successes and how many failures that we had. So let's try and do the math here. So I have 20, C, 18, and then that's multiplied by the probability of success. Well, getting ahead, what's the probability of getting ahead? Half times 18 times getting ahead times the probability of failure, which is still a half, times the 2 that I get there. So that's how that formula works. 20C 18, 0.5 to the 18th times 0.5 to the second. I'm going to do this one on the calculator so that you can see it too. Clear. 20. Oop, lower this up for me. That way in there close. 20. I go to my math key, probability, and CR. That's a huge 18. Because it doesn't matter which coin got the head on it, right? As long as it was just 2 of them. So order doesn't matter if it was the third one and then the 7th one, or the 7th one and then the third one. Okay. 0.5 is the probability raised to the 18th power. I have to hit my right arrow to get it down. Times 0.5 raised to how many times I don't get ahead? 2. And I get that. And you're like, what the heck is that? Oh, okay. You see it again? That is scientific notation, which means because it's a negative number, I have to move the decimal place 4 places to the left. 0.00018. And I don't know what they're going to ask for. Oh, to the thousandths. To the nearest 100 thousandths. Oop, get another one. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. There we go. 0.00018. Cool. This one says the next one. Oops, sorry. Apologize. I had that zoomed in on the calculator, so let's go again. So changing the scientific notation of my calculator to a decimal, 0.00018, 100 thousandths, tenths, hundredths, thousandths, 10 thousandths, hundredths, thousandths. Okay. Now it says calculate probability of flipping a coin 20 times and getting 20 heads. Like, no. So small. I mean, like, my guess is that you'd have to flip it almost 1,000,000 times for you to have an outcome where you actually get 20 heads in a row. Maybe smaller than that. I don't know. It's pretty rare. Highest probability would be getting 10. So if I did have this, and you could do the formula on your own, but if I did have this, let's watch the whole thing. So 1 head, 2 head, 3 head, 4 head, 5 head, 6 head, 4 head, hot, 20, 7, 8, 9, 10 heads. That's the one that's going to have the highest probability, and all the rest of these things are going to be step down here, lower, and the ones down here are going to be so tiny, so small, I could barely even recognize them. So this one's going to be really high chances of getting 10 heads out of 10 flips, 9, and then of course it should be symmetrical for this. For 11, 12, 13, 14, and 15, all the way up to 20. Okay? Again, 20 is going to be so small, barely even would register it visually if I did all of these things for all of those different ones. Okay. Flip the page. This is, oh my gosh, this is the last one. You see, I didn't ask for a lot from you guys from this stuff, but I do want you to see it. So this one says, describe the error in calculating the probability of rolling a 1 exactly 3 times in 5 rolls of a 6-sided die. So I do want to point out a couple things. Is that on this one you can see, since it's a dice, I'm rolling a die, a 6-sided die in fact. Since I'm rolling a 6-sided die, since I'm rolling a 6-sided die, that the probabilities now change. The last one, these things were 50%, right? Now those things are 1/6, or 5 out of 6. So there's only one, a 3. You can only roll a 1 one way, right? Now if this said roll an odd number, then there'd be 3/6 on that one, and this would also be 3/6. Or if it said roll a number less than 5, then there'd be 4 out of 6 possibilities. So you really got to check each time, what is the probability of what you want probability of what you want. And that goes right in there. And then whatever it is minus 100% goes right in there. Okay, so again, hope that was a great thing for you. Hope it worked out for you. Hope it made sense. And we're all good. So you guys take care. This is Mr. Bells. Keep doing well. And we are on our way to getting credit for this class. See you guys.